Happy to be here, everyone. My name is developer Uche. I'm a blockchain engineer, and today we'll be looking into Solidity and how it can be of help to an on-chain analyst. So I'll go ahead to share my screen now. If you're with your iPad, your notes, your laptops, just have somewhere you could write some stuff down. I'll be sharing some resources, some tools, and let's see how we go. So give me a thumbs up if you can see my screen. Just a thumb up, something that would give me a glimpse so you can see my screen. Awesome. Yes. So today we'll be looking at Solidity. But we can't look at Solidity if we don't look into the EVM blockchains. So we would have some kind of and we'll see how it goes from there. So the objective or the agenda for this talk or for this masterclass is to equip you all with the skills to be able to look at a Solidity contract, understand it. If you want to modify it, know what to modify, what it does, or whatever you change. If there's any question, please just drop it on the chats. I'll be coming back at intervals to check it out. So yeah, I'll be teaching you how to read a Solidity contract, how to understand it, know what's happening in it, know some fundamental stuffs about Solidity, what it does, and how it can help you as an on-chain analyst. So we'll be taking this in sessions. The first session, I'll just be doing a very, very quick reintroduction to the blockchain. Then we'll look into EVM blockchain and some specific characteristics of the EVM blockchain. Then we'll look at the transaction life cycle. Then we'll look at smart contract in detail. Then we'll look at Solidity. We'll take an example, ERC20 token, and we'll look at USDT smart contracts on Etherscan. I will try to break some things down, trying to understand this contract, and I'll be training questions, and hopefully you understand everything I'll be saying. Then have a bonus section. I'll be showing you a tool which we developers make use of, which I think is going to be essential for on-chain analysts. It's a way we could use to look deep into a hidden kind of transaction, and in such a way that Etherscan cannot give us this kind of detail. It's a way we can even re-simulate the transaction and to know what happened. We'll be using something like a Uniswap transaction to see that example. So that's going to be the second to last thing for this talk. Then you throw me with some questions, and I hopefully have the answers to your questions. So we will dive right into it now. So now I'm not going to repeat it for some people, but we want to carry everybody along. Me redefining the blockchain to you again. You're an on-chain analyst, so you know what the blockchain is. But either way, I'll do it, so I'll just be sure I'm carrying everybody along. So the blockchain is a distributed ledger. Just see it as a database that is shared across many computers, and this database holds record of all right. Sorry for that. So you see it as a database that is shared across various computers. These computers are called nodes, and this data that is inside this node are blocks, which are cryptographically linked together. So you can just call it cryptographically chained together, hence the name blockchain. So once the block is added, it's not mutable. And here are some characteristics that is important to us analysts. One is the transparency of the blockchain. Every public blockchain, anybody can just view data within that blockchain. Things like transactions, events, contract data, balances of an address, any data on that blockchain publicly available for anybody to take and draw insight from. So second characteristic is verifiable. All the data stored in the blockchain is revalidated across all these computers that is storing this data. That's why when you send money across the blockchain, you are confident that there is no replay of this transaction, or there's not going to be a false alert on this transaction. So that's highly verifiable. The data is with high integrity and tamper-proof, because the blockchain is immutable. You can't just update data across the blockchain without updating all the data across all the computers holding copies of this data. So high data integrity. So it's important to know that blockchain is not just for cryptocurrencies. Blockchain hold vast amount of data for many purposes. Some purposes include elections, governance, banking, and many other things. So it's important to note that. So here are some core concepts that you'll be hearing a lot while we go through this workshop, which is one, transactions. So transaction like the fundamental unit of the blockchain. Whenever you want to do anything on the blockchain, you send in a transaction. If you want to make a call to a smart contract, you're sending a transaction. If you want to send it or any native token from your address to another address, you send a transaction. So the next thing is block. So block is a batched number of transactions. So some blocks hold about 98 transactions together and process it and chain it to another block. Chain, hence blockchain. So nodes, these are the computers that are actually validating these transactions and chaining all this, batching all these transactions, chaining the blocks together. That's all they do. And because there are many computers, they have to agree on a particular state. And that's what the consensus mechanism is for. Majorly, there are two kind of consensus mechanisms. There are many, but we usually use two in practice. The other one, there are many other flavors of them. So one is the proof of work, which Ethereum was using once upon a time. Bitcoin still makes use of it. And now Ethereum uses the proof of stake consensus mechanism. So we just do a quick overview on EVM blockchains. So EVM blockchains are blockchains that have which its execution sandbox is an Ethereum virtual machine. So don't think about it too much. Just know it as it's an environment that can run Solidity smart contracts. That's all it is. Don't think about it so much. So there are many EVM compatible blockchains these days. One is Polygon, BNB Chain, Avalanche, Phantom, on and on and on and on. So because of there are many EVM compatible chains, an analyst who is skilled with extracting data from EVM blockchains, drawing insights, maybe for security purpose or for financial purpose, is highly in demand because of the high diversities of these EVM compatible chains. So EVM chains also rich in data from DeFi, NFT, DAOs, USDT contracts, and all this other contract that serves as a bank on chain, something like USDT, USDC, USDE, and all those dollar-tied or dollar-backed cryptocurrency. So there are also transaction data. So these are like things that analysts are interested in with regards to the EVM blockchain. There's also state data. So state data include things like what is your balance at the ERC20 contract called USDT. So this kind of question is kind of, oh, if you go to the USDT contract and I place in my address, how much is the balance it's going to return to me as mine? So that's those kind of data are classified under state data. So EVM is also standardized because of many blockchains make use of it. When new upcoming blockchains are being built, they kind of try to accommodate the EVM virtual machine. They try to be compatible with the EVM virtual machine because many developers now can write Solidity. Many analysts now can analyze Solidity contracts and data being vetted from Solidity contracts. So any blockchain coming in now, it will be at their detriment. So they're trying to like reinvent the wheel or the wheels if they don't, if they are not EVM compatible. So here are some data or some data points analysts will be interested in. So one is transaction data. Another one is contract interaction, event logs. And this is the most important will be, we have another session still in this workshop dedicated to event logs. So, you know, we, sorry about that. Let me quickly turn this. So we said earlier in the transactions as the units of an EVM blockchain. So we'll be going through the life cycle of a transaction. So when a transaction is vetted until this transaction is mined or validated. So when I say mined, it's for a proof of work blockchain. When I say validated, it's for a proof of stake blockchain. So the first stage is where this contract is, where this transaction is created. So we use things like or MetaMask to maybe send some tokens, and we click send. And that's the first stage. So during this stage, we kind of put in the details of the transactions we want to do. We want to call the smart contract, the address of the smart contract, the data of the smart contract is going to be there. Then we hit sign. So at this point, we create this transaction and we sign it with our private key, which is stored in our MetaMask. So next up, it's broadcasted to the network. So because the blockchain nodes are interconnected in this sense, when you send the transaction to one node, let's say this is an Infurian node or an Alchemy node, it's going to gossip it to all the nodes on the network until it's propagated to all the nodes on the network. So the next stage is when this transaction is propagated to the network, where is it stored? It's stored in a point they call the mempool. So transactions are held temporarily at the mempool until they are validated and included into a block. So the next phase of this transaction lifecycle is block inclusion and like proposition. So if it's a miner, so the person that mined this block, that's the person that did this hash competition for the case of Bitcoin, or the person who is chosen by in the case of a proof of stake blockchain, they're going to pick transactions from the so this node is the one that is selected to mine this block. This node just maybe actions and chain it to its own block. It's going to broadcast that, hey guys, I just created a new blockchain. And all the whole blockchain is going to take the data, that's all the transactions, in this case, that's the data right now, and re-executes what this guy just computed, that does this batching all over again, and validates that the results that this guy propagated is correct. Then everybody's in agreement. And that's where confirmation and finality comes. So when everybody agrees that, oh, this block is correctly created, all the transactions in this block are all valid, then the blockchain gets into the state of finality. The state of finality is when nothing can change again. Blocks at this point cannot be reversed. So that's where the immutability of the blockchain comes into play. So let's see. All right, I think we're all good. So I'll be going into the EVM blockchains and events. So as an analyst, 90 to, okay, let's say 80% of the time, the data you analyze is being created by something called event. And it's fundamental you understand what these events are, how they are created. And I'll be showing you some examples in the smart contracts we'll be analyzing, so you can like see how it is in Solidity code. So whenever smart contract does any action, say you transfer USDT from you to my address, or from my address to your address, the smart contract screams out an event, and anybody in the world can listen for that event and do what they want with that event. So if I rephrase this, when you send me USDT, or I send you USDT, the USDT contract screams out an event, and any analyst in the world, or any analytical tool like Dune, like Subgraph, like decode, or anything like that, can pick these events and draw whatever insights they want. It could be they want to know how much USDT has been transferred today. So they'll just look for the event called transfer on USDT. So we'll be looking into that as we go further. Oh, let's just keep going. So think of event like breadcrumbs or footprint left behind by operations done on a smart contract. So as things are happening on the smart contract, it's leaving footsteps behind for smart persons, smart analysts to pick and say, oh, this is the direction the blockchain is going to. This is the amount of transactions happening today. This is the volume of ETH that was moved today. So that's what events are. So let's see how an analyst can make use of this event. So this is from footprints to insights, because analysts, data is very powerful. Like data is what's driving most of this top 500 Fortune companies. Google strives on data. You strive on data. So data is very powerful. But data is useless if you can draw information from it. So an analyst's role with this data, with these breadcrumbs coming out from the blockchain almost every second, is one, gathering. Because the blockchain is a distributed network of computers, querying the blockchain every time for this data is slow. And if you're running a machine learning model on, let's say, on Google Colab or something, you don't want to be querying the blockchain for the data while your machine learning model is training. You want it stored locally or in your Google Drive somewhere. Gathering data, and there are many you can use to do data scan, like subgraph, like D graph. So this and also you can use Dune. These are like tools that index the blockchain and also give you like some CSV files that you could use to maybe run a Python analytics on that data. So the other one is structuring. So this is where you organize this data and this, some, because the blockchain does not store data like in English. We store it in something called RLP encoding. So when you get this data, you need to like sort them out in a way that it makes sense and you can easily draw insight from them. So that's where you do things like the contract ABI dot decode or dot encode on that kind of data. So lastly, you do analysis on that data. So now you've gathered the data, you structured the data, you want to now get insights from that data. So yeah, the goal is to transform this not so useful footprints into actionable intelligence. The goal might be, oh, you want to know how much volume moves in DEX all over the world when the London Open Forex time happens. So you want to know, oh, maybe this London market influences the market, the global markets by 20%, then the Tokyo by this also percent, and it could give your company some insight to know, oh, if you want to buy some assets, this is the best time to buy some assets. So these are just some scenarios that this event breadcrumbs, footprints can be helpful. So before I dive into smart contracts, is there any question? All right,
Yes,
along.
if any question, you can just raise your hand like I did, like this. So yeah, if there's any question, just raise up your hand.
All right, so all right, along then. So now we look into smart contracts. So smart contract is the major selling point for EVM blockchains. So before the EVM blockchains, or before Ethereum, let's put it this way, we had Bitcoin. And Bitcoin, the kind of agreement you can do on Bitcoin is, I send you some Bitcoin, you confirm you've received it, and I've settled you. Just more like I transfer money from my bank to your account and you receive it. So that's the kind of agreement that can happen on the Bitcoin blockchain. But we needed more. Having to do this kind of agreement without my bank being an intermediate was wonderful. So now I need to do more kind of agreements without having an intermediary. So that's what bettered the EVM. So the EVM is that execution environment where this agreement can be run on a blockchain like Ethereum, BNB, Polygon, yada, yada, yada. So I wanted to just see smart contracts as digital agreements enforced by the blockchain. And in this case, the language that we're going to use to write this agreement, just the way we use English to write an agreement for maybe some land deeds or some contracts, work or something, and sign it with our signature, the language we're going to use to write this digital agreement is the Solidity language. So the Solidity language is the primary language for the EVM blockchain. Example, so these are like, this is just more like a very, very simplified introduction to what is Solidity, I think you should be more interested in the structure of Solidity, which that's where we'll spend some more time in. So if you don't understand some programmatical jargons here, don't worry about it. Try to make sure you understand the structure of Solidity contracts when we get to this point. So it's statically typed. So it's not like JavaScript that you can just declare a variable and the variable can hold different types. So it's influenced by this programming language, just C++, Python, JavaScript. It's designed to target the EVM, the Ethereum virtual machine, which has EVM and its compatible chains. The purpose is to define rules to manage assets. Example, that's the native token, USDT, USDC, and all those wonderful meme coins that I used to dump. So another purpose is to automate agreement and process, and that purpose is to run predictable, transparent, or predictably and transparently on the blockchain. So this is an example contract. So I had my AI tool write me a smart contract that used almost all the whole syntax that a programmer, a Solidity developer would use on day-to-day. So it's quite long. So I opened it in an editor called Remix. So I'll just drop a link on chat. It's not going to open my particular code to you. It's just for you to just have this editor to yourself also, because when you are simulating a transaction soon, you would find it very helpful. So this is a smart contract that used many Solidity syntax types, primitives, and I'll be explaining what these types are and what they do. So, the goal of this talk is not to get you to be a Solidity developer, is to get you to be able to see a Solidity contract, be able to read it, and if you want to change anything, you should know what you're changing and how it influences the data that you would get off it. So the first thing you will see most times in a Solidity contract is something they call state declaration. So this is where you create some variables, some data that the smart contract logic will be making use of. So to create this data, you need to do something first. You need to write out the type of data you want to create. So right now, I want to create a UINT 256 data. So this is the data type that is used to store numbers. So the balance of your USDT contract is stored using this type. So the next thing, you want to write the visibility of that variable. So the visibility of this variable is public, meaning when I deploy this contract, anybody can check what the value of this variable is by making a call to it using Etherscan or using some JavaScript code or some Python code or whatever programming language that can interface with the Ethereum blockchain. So then after you've placed in the visibility, and this is public, then the name of the variable. So you just use public uint. Then you assign the value into that variable. So with this, you've declared a variable in Ethereum. So next up is another variable type, uint8. So this uint256 holds 256 bits. So yeah, you should not be concerned with this because if you're not a programmer, you should not have to think about the space that the variable can hold. Just know that it's just numbers, just smaller numbers in this case. But this time around, the visibility of this variable is private. So meaning when I deploy this contract, you cannot just ask this contract what is currently stored in this variable. The contract is not going to tell you because it's private to it. So if you want to read it, you have to just use some more fancy way, and that's out of the scope of this class. So the next is int 256, also used to store numbers. So the uint means unsigned integer of 256 bits. This one means unsigned integer of 8 bits. This one is just an integer of 256 bits. So this integer can store negative value also, but this can't because it's unsigned. This is signed, so you can have the sign of negative or nothing there, which will just mean positive. So another variable type is Boolean, and of course, public, the name of the variable. So this just holds true or false. So address, this is the one that is unique to the Ethereum blockchain, because if you have written Python or TypeScript or JavaScript, you should have come across some kind of variable that does something similar to this. But this address, you most likely will only find it in Solidity or any smart contract language for a blockchain. So this just holds the address of a user that's an externally owned account or a smart contract. So the visibility, public and public here. So when an address is marked payable, it means this address can receive the native token that this contract will be deployed to. So if I deploy this contract to Ethereum, this contract will be able to receive this address, sorry, will be able to receive it. So if I deploy it on, let's say, Polygon, this beneficiary address will be able to receive the Pol token. I guess they're not using Matic anymore. So this byte 32 is also a data type. Similar to UNC 56, it holds 256 bits because it's 8 bits makes 1 byte, and 32 times 8 is 256. So this one just holds an endless amount of bytes. This one is bounded to 32. This guy is not bounded. Let me post this a bit. So there's to code a string. So this one is quite popular. So this is an enum. So this is an enum is similar to a Boolean, but now it has more options. For a Boolean, we just have true or false. But in an enum, you can customize it to many other options that you need. And you first declare an enum, that like you create the type before you use it somewhere here. So use it this way. I'll be dropping this code later on with this link, so you could like look at it in your spare time. So this is a struct. So this is a way to create this same kind of data structure, but encapsulated into a particular data type. So this is a way to create custom structured data types in Solidity. So in something like Uniswap v4, they have some types like this representing the pools, some types representing the delegators, and it holds different informations about how many tokens is in the pool, how many, what is the liquidity ratio of the pool, and some other unique informations concerning a pool is holding this kind of structure. So similar to the enum, you first declare the structure before you make use of it. And this is how you make use of the structure. Remember, the type then visibility, then name. So next up is mappings. So mappings is a way to map is a way to make a relationship between a key and a value. So giving that key, it returns to you the value. So this is how your balance is stored in a USDT contract. And UINT 256. And it is then called, it's made public. Of course, you would want to know your balance, and it's called balances. So an example of this would be address of developer Uche to some amounts. So let's say 50,000. So this is how a mapping looks like, and it is fundamental to smart contract development. Without this, it's going to be very hard to have something like tokens, like USDT, USDC, yada, yada, yada. So these are how you declare arrays. We'll not spend time here because it's not often used. And since we've looked at the types, if you need to use them, it's going to be quite easy to look into. So we've stumbled on this guy again, events, and I want to spend some more time with these events. So, as we mentioned earlier on, over here, events at breadcrumbs for analysts. When anything happens on the blockchain or on a smart contract, the smart contract screams out an event that details what just happened. So as an analyst, you could come pick from that breadcrumbs and you know that, oh, something was withdrawn from this contract. Something was transferred off from this contract. This is the social amount that was transferred out, and this is the person that transferred out this amount of tokens. So that's the role of an event. And this is how you declare an event. So you first write the keyword event, the name of the event, then open parentheses, and put in the value of the this event will be screamed out at. And don't mind me, I'm using scream. I'm just trying to put in some emphasis. The main word there is called emitted. Events are emitted from smart contract. So in this case now, this event is emitting out the updater of that variable, the value that the variable was before, and the new value that the variable is right now. So I'll quickly go to show you where it's being used. So when somebody calls this function, so this function will take in the new value of this UINT and update this public UINT from the old value to the new value. When this happens, it will scream out this event, hey, the public UINT has been updated. And this is the person who updated it. This is the old value. This is the new value. So that's it for events. And would also look into the USDT contract. Real quick to see how they did this. Okay, we'll be back to that. Is what's called modifiers. So modifiers are just an intercept a smart contract and place in some rules. So this is a rule that says only the person that deploys this contract can modify the function, or can modify the, we can access the function where this modifier is being placed. So this is how the modifier is being used. So this is the function sets a private uint value, that's uint 8 value. So since this is private, I only want the person who deployed this contract, which is most likely me, to be able to update it. I don't your token. Say, oh, if now is of this token is Uchi, and he's the same person trying to transfer it, then it can go through. But if it's Samuel that's trying to transfer Uchi's token, decline. So that's that for modifiers. Next up is something called constructors. So when a smart contract is deployed, the first thing that runs is the constructor, and it's responsible for setting the states, or some of the states that have been created up here. Some of these states are created, but no value has been assigned. So no value is assigned because the constructor is going to be assigning some values to it. So some of the things that we'll be doing here, like setting up the deployers, the contract deployer, which is going to be me. So this MSG, the sender, is the person that sends the transaction that is creating this contract. Remember, everything you want to do on the blockchain, you have to send a transaction to it. If you want to deploy a contract, you send a transaction. If you want to interact with the contract, you send a transaction. If you want to send it, you send a transaction. So the person sending this transaction can be gotten from this variable called, or from this environmental variable called MSG dot sender. So with this now, I'll set the contract variable, that's the contract deployer variable. I'll set it to this address, which is most likely me. And later on, this modifier can make use of it to ensure that I am, that current caller of this contract is always the person that was set here, which is me. So when I deploy this contract and you try to call a function that is being guarded by this modifier, it's going to decline and tell you, hey, caller must be, the caller is not the deployer. So next up, we'll just look at few of these functions, then we'll head down to some other stuff down there. So next thing we're looking into is functions. So functions is more like the terms of the terms and conditions of or let's just put it this way, contracts and functions are just the terms of the contract, while things like modifiers are the conditions of the contract. So the terms is more like these are the things you can do in this contract. So you can transfer, you can approve, you can approve somebody to spend on your behalf. So all those kind of things, those are like the terms. And in this case, this function, it's responsible for updating the variable public uint. So to create a function, you first write the keyword function. Next up, the name of the function, and you open parentheses, then the variables that this function is accepting. And these are like some internal variables that you can use to do stuffs inside the function, and after the function is executed, the variable is discarded. Then after the parenthesis, that's after putting in your variables, you then include the visibility of this function. Do you want this function to be public? Do you want it to be private? Do you want this to be internal? So in this case, we want this to be public because, of course, it's a public event and you want anybody to be able to update this. That's what the contract is for. So that's the current terms for this contract. So after updating this, we emit an event saying these contracts uint and public uint variable have been updated. So I'll go down quickly to something that is not a function, which is this guy. So by default, a smart contract cannot receive native currency. So I'll take it again. By default, if I deploy my smart contract on Ethereum, if I give you my smart contract address, it cannot receive the ETH token. So if you try to send ETH token to that address, it's going to decline. It's going to bounce. It'll tell you invalid transaction. So a contract cannot receive ETH because of this function is not available. So for me to be able to receive ETH, I need to include this function, which is called the receive function. And it's different from every other function. It's a reserved function. So you see, you don't have to write function here to do this. You just write receive, then external, then payable, because this is going to receive native token, in our case, ETH. So when we receive this ETH token, we want to emit an event saying, hey, some funds have been received. And this is the person who sends the funds, and this is the amount of funds sent. So to get the amount of funds sent, we still go to the same environmental variable, MSG, then dot value. So value holds the amount that is being sent pegged to a contract alongside a contract call. So with this like ends the overview of Solidity introductory syntax. Is there any question? I'll wait for 10 seconds. All right. So we will ride along. So next up, I want to look at the USDT contract, because no, this is a play contract. Yeah, you're not going to encounter this contract while you are looking. So unfortunately, zoom in this. Yeah, I wish I could extend this. Okay, but it's fine. Yes, so this is the let me use. Yes, so you know USDT, it's called Tether, and the name of the contract is Tether token. So I think that's convenient. So the Tether token have functions like transfer from, balance off, approve, allowance. This one is duplicate. Okay, total supply, issue, and redeem. So then this one has basic functions and some event also. So we'll be looking at all the all the functions that they're making use of, and we'll try to like see some syntax that we discussed over here, and hopefully it makes some sense to everybody. So the first function is the tether token. So this is a very, 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 very old smart contract. It's version 4.0, if I'm not mistaken, or 4 point something. Yeah, 4.17. So back in the days, this is how you make it of a constructor. So the code that runs before your contract is deployed, that has to set some state variables. So this is how you do it. So the exact name of your contract, you just write a function and put in the exact name of your contract. But that's not important. Just know that this is a constructor. And in modern contracts, as you do your analysis, you would most likely be saying constructor rather than function and the contract name. So this is the parameters. When the tether token was deployed, they had something like the initial supply, the name, which is USD tether, the symbol, which is USDT, the decimal, which is 18. And of course, it's public. So the first thing they did is they took the variable total supply and they set it to the initial supply. So maybe they started off with 1 billion USDT and as their initial supply. And the name, they set it to the parameter, which is USD tether, the symbol USDT, the decimal 18, then the owner, that's the initial supply. They assigned the initial supply to the owner of the contract. Then duplicated is false. So here are some functions that they make use of. So the first function is the transfer function, which almost everybody on this call have most likely used. So it's just used to transfer function from the caller of the function, which is most likely going to be you, me, to the specified address to the value that is to be transferred. It could be 50 USD, it could be 100, it could be 1,000, it could be a million, whatever that your balance can carry. That's what that's going to be. So the first thing they check, we want to see if this person calling this contract. So you see that MSG.sender. So it's a way to know who created the transaction that is calling this contract USDT. So they want to check if this person has been blacklisted from USDT or from using USDT. So you see, that's why most times when people do like a hack, like something from the hack from on Bybit that took about $1.4 billion. When they do this kind of hack, they don't convert the money to USDT because the Tether corporation can blacklist that address and money becomes useless on that address. So next, they check if this contract have been deprecated. If it have been deprecated, then they would use the upgraded version. If not, they then perform the transfer. And this is just an inherited transfer, which is somewhere up here. Where down? Yeah, somewhere here. So this is how it works. So forget about the fees. The fees have been made zero, but when they deployed initially, when you transfer your USDT, you pay some fees in USDT, not just in it or the native token of the blockchain. But now you don't do that anymore. They make money some other way by investing your money. So the transfer function that was being called, that after they've checked if the image, the sender, the caller of this function have been blacklisted, They then check if you have enough money. They first calculate the fee and check that you have enough money to pay the fee. Then they subtract the fee from your balance. That's value.sub. Then they transfer the balance, they transfer the amounts that you are sending. They first take out the balance from your own balance, sorry. So this is where they put in the fee into the amount that you are sending. Then they subtract the value from your balance. Then they send the amount after removing their fee. They send it to the toll address. So after they send it to the toll address, they check that the fee is greater than 0. That's the fee you are transferring out. Well, the fee is calculated based on the amount of money you are sending. So once it's greater than 0, then they will transfer that fee to the owner of the contract, which is the USD and the Tether Corporation. And later on, at intervals, sometimes monthly, sometimes bi-yearly, they can come and take out all the fees and maybe use it to pay some of their staff salaries or to pay dividends to their shareholders or something of such nature. So that's it for the transfer function. We'll just look at one more function, then we take the last session of the slide. So we'll use balance of. So the balance of function is just a function that will provide an address and it gives you the balance of this address. So when you call this function balance of, you give this function an address. Hey, USDT contract, I want to know how much USDT this address owns. So this could be my address, this could be your address, it could be someone else's address. You just want to know how much USDT this address owns. So that's what this function is used for. So first thing it checks if this contract you're calling currently is deprecated. If it is, it's going to call the upgraded version. If it isn't, it's just going to call balance of from the inherited contract. So let's look at the balance of from the inherited contract. Yeah. So what it does, it goes to that mapping. So it's very let's look at the balances mapping. So if you see this, it's almost exactly what we used here. So it's mapping of address to uint. So uint was how uint 56 used to be used or used to be instantiated in the older versions of Solidity. And the visibility of the balances is public, so anybody can like query to know how much balance they have, and the name of the variable is balances. So in this case, I can put in my address, developer Uche, and it spit out 50,000. So that's it for this contract. So I'll implore you guys to look at this contract and see how this contract works and try to like get more glimpse on Solidity. So that's it for this. So in the second to the last session, we'll just look at we have just seen an ERC20 contract. So we want to just simulate an ERC20 contract on this IDE and deploy it to a local blockchain node and just transfer from and to the contract. So I just created a contract called the Sage tokens or the Sage token. So this is similar to how USDT is with the transfer from, the approve, the balance of, and the allowance and all those stuff. So we'll just the reason why I'm doing this is so you can see that you don't need to like run Solidity on your VS Code where you need to like download the Solidity compiler, you set up the Solidity extensions on your VS Code to do all this. You can just come online, head to remix.ethereum.org and just open an online editor and do everything you want to do, and you are done with that. So first thing you need to do to compile this is to come here and click compile Sage tokens. So when you click this, it compiles this targeting this version. So if you recall, USDT make use of the 0.4.17, but we don't want to use that. That's too old. So compile, and we come over here to deploy this contract. So we'll be deploying it in our local Remix virtual machine. It runs on my browser. And on this account, I'm very rich. I have many accounts. I have over 100 each. So that's wonderful. That's enough test tokens to play with this. So if I'm creating this token now, I want to name it Sage tokens. I want the symbol to be AST. I want the decimal to be 18. And I need the initial supply to be 1,000. Let's make it 1,000. So after I put in all these parameters, all these parameters came from the constructor, because this is what would run before the contract is saved into the blockchain storage. So that's the name, which is here, the symbol, which is here, decimal, which is here, then initial supply, which is here. Then I transact. So at this point, it has deployed my smart contract for me. And this is what my smart contracts compiled to. This is what they call the bytecode. This is the gas that was spent creating my contract. This is the transaction cost. This is the execution cost. And here are the logs that was emitted. And this is the raw log. So as a data analyst, these are like some things you'll be interested in. Example, this log. And let's look at why this log was emitted. So in the constructor, we emit a transfer event from address 0 to msg the sender, that's me. This is my address creating this transaction and the initial supply. Because when we deploy our ERC20 token, we want an address to hold the initial supply that can transfer out to other addresses as time goes on. And that address happens to be my address. That's going to see, you can see that in this log. In the log, it's the from is the contract address. The topic is, don't worry about this. This is just more like an ABI encoded format of this transfer address UNT 256. But don't worry about that. That's not so important. The name of the event is called transfer, and the arguments are address 0, msg.send B3, you see 0x5 B3, blah, 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 blah. And the amount that the initial supply, which is 1,000. So to do more stuff with this contract, I can now interact with it from here. So I'll just do one more thing with this contract and we are done with this example. And that's to transfer tokens from this address to another address. So before I transfer, I need to just check what's the balance of this address right now. It should be 1,000 if all is well, which is correct, is 1,000. So I want to transfer to one of my other accounts. I'll copy this address and I would transfer. This is 2, and the amount I want to transfer 100. So I hit transact and it has gone. So I need to just check what's the balance of this my friend I just transferred to, which is 100. So when I check my own balance, it should reduce to 900. So it's 900. So this simple thing you just see here, this is exactly how the USDT contract that holds over 140 something billion dollars works. And that's kind of wonderful. So at this point, we are done with this masterclass, remaining the bonus section. And before I look into the bonus section, I'll entertain some questions. Any from the class?
All right, all right. If you have any question, for those who might not want to, speak, you can just type it in the chat. Okay, if you have any question, just type it in the chat. If you want him to review a part of, what he has discussed, you can also ask.
All right. So I'll just wait for another 10 seconds for questions. If there is no questions, I'll just go to the bonus part of the lecture and we would be done. How can we interact with contracts with a dApp? So if the dApp is with a programming language like JavaScript, TypeScript, let's say the dApp is written in something like React.js or Next.js or Vue, anything TypeScript, JavaScript, you can use these tools, ethers.js, wagmi.js, Vim. Vim.js. So the other question is, how do we use SQL? So this is the catch. You don't use SQL. How do you use SQL to query SQL for query M? I assume you mean how do you use SQL to query the blockchain, to query the Solidity contract? So you don't use SQL smart contract itself. So there are tools that index these events. These events that is emitted by the smart contract. There are tools that index this event, tools like Dune, tools like the graph, subquery. So their job is to index these events. So as the event is happening, they'll copy it and store it in their server. They'll copy it, store it in their server, copy it, store it in the server. Then you as an analyst, you then use SQL to query their server for this data. So you don't just query the blockchain using SQL. So the point of this is now, how do you the point of this class is now, how do you structure the data that will be emitted by the smart contracts for you to gather and store in another database where you can query it with SQL or use a tool like Dune to store this data, these logs, these events emitted logs, to query them using SQL. I don't know if that makes sense. Yes, so in the blockchain data, so this question, in the blockchain explorer, can we decode the log? So yes, you can, if the contract is verified. So something like the USDT contract is a verified contract. So so in the bonus section of the class, I'm going to show you how you can re-simulate a transaction that already happened and go through a trace on what happened in that transaction. But let's just quickly look at the USDT contract and pick the latest transaction. So this is a transfer transaction, and it should have some logs. Okay, have just one log. So you see, this is the raw data that it's supposed to show you. Because it's verified, it will show you the decoded format, which is transaction and transfer. That's the name of the event. It has an index address from topic and that index address to then the amount of transfer, amount of USDT that is being transferred. And because this event is this contract is verified, that means they uploaded the raw contract file to Etherscan. You can decode it to know, oh, the from address for this log is this address ABBDAE7 blah blah blah, and the to address is A4 4FB blah blah blah, and the amount they are sending is 8,000. Not this, not 8,000. This should be $8 or $80, one of them. So because of USDT's decimal is 6. So to know this amount, you like count 1, 2, 3, 4, 5, 6. So this is Michael, please leave me alone. 1, 2, 3, 4, 5, 6. So this person is sending out $800,000. I hope that makes sense. It can be found at tenderly.co. I think there's a hand raised. All right. So you can find this tool at tenderly.co. So this is a tool you could use to trace what happens in a blockchain transaction. So this is the transaction I want us to analyze. So this is a transaction to swap it to what are we swapping to? To swap it to Kudu or Kendu Inu token. I don't know why this guy is buying this amount of meme coin, but he must have some information to do this kind of financial wonderful behavior. So once you analyze this transaction and see what happened inside this transaction, so Etherscan can try it. At least with this, we can know from this point, by just having a transaction hash, we can know that, oh, this transaction, this person was trying to swap some ETH with 4-3 it to some amount of can do Inu token. But with this tool called Tenderly, it's going to give you a more verbose analysis. So it will go down to telling you all the tokens, all the contract that this transaction interacted with. So it interacted with the sender's address, of course, it's the originator of this contract. And after this contract executed, this sender got this amount of can do Inu token. This is about 220 million of this token. So it interacted with another contract called wrapped it. So it also interacted with another contract called the Uniswap V2 pair. It also interacted with the Kendu token and also interacted with the wrapped it token. So this is now where it gives you an analysis of all that happened during execution. So when it started, the first contract it reached was the Uniswap router. So this is the one that routed it to where it's going to deposit it to receive wrapped it, then goes to deposit the wrapped it to receive the set token A, which is most likely the Kendu Inu token. And after that, this is showing where the wrapped it is deposited. There's depositing fee to the Uniswap V2 contract onto the pool. This is where the swap is being instantiated. This is where the token is being sorted. This is where you get the reserve of the pool to know the price that the Kendu Inu token is going to be. That's the amount of token that you'll be receiving for the amount of it you deposited. So that's where that happened. And this is where the amount of the Kendu Inu token was transferred, which is the 220 million tokens. And this is now where all the fees related to this token was done. And this is now where the pool rebalanced. And this is just I chose this contract, this transaction because it's kind of complicated. So just to show you elaborately some things you can easily do with this tool called Tenderly. So just before we go, we can now easily resimulate this transaction. So I wanted to use the Bybit hack to do this test to simulate how the hackers hacked the Bybit wallet, but that transaction was not easy to get from Etherscan. So we'll just be simulating this one. So this resimulation now is more like I can take a transaction that have already happened and I would try to resimulate it and edit some parameters to know what is going to happen if this parameter changed. And I will not have to pay any gas fee to test out this hypothesis or to test out this analysis. I can just simulate to get some certain point that I'm looking for. So I don't intend to change this to do anything. I can just simulate this transaction. And gives me the full trace again, showing me, oh, this transaction is going to take out this amount of ETH, this amount of Kindle Inu token is going to be deposited. So if you look here now, the amount of Kindle Inu token reduced. There was about 500 and something in this position before. The reason is because we are resimulating this transaction at a later time, the pool has changed, that the price of the candle in no token has dipped a little. And so these are like some data points you can just like grab, like a transaction that happened 10 days ago. What will happen if that transaction had happened now? So if I had swapped my USDT to this candle in a token 10 days ago, and I got about maybe 500,000 candle in a token. What if I swapped it today? How much would I get? So with this $10 tool, I can just re-simulate that without having to do that transaction for real. So with this, I think we come to the end of this class. Is it possible to trace this transaction event from the ABI code in case the contract wasn't uploaded? Yes, but with Etherscan cannot. You cannot do that with Etherscan if the contract code was not uploaded. But with Tenderly you can, because with Tenderly, let's see, you have a place called contracts, where this is a contract I analyzed some time ago. So in this Tenderly now, because you have total control, you can now upload the contract from your computer to this website. I don't know why it's taking some time to load. Yep, it's loading now. So source code. Let's just create a new contract. So if you add a contract, you can let's see, let's get a contract address. Where's this Kindle in no token? So let's get this address. So with this now, you can, in the next place, you can now upload a contract file. But I will not have to do that because I'm guessing the candle in no token is what's it called? Is already like uploaded to Etherscan. So although I will not have to do that, but if you had to, you just upload the file from your local computer to this contract here on Tenderly, and you'll be able to analyze it way more. Okay. I think my network broke off for a bit. Said, what's no, the network is terrible today. It says, what if you are not the contract developer? So if you are not the contract developer usually push their code to GitHub. So you can go on GitHub, clone the repo, and upload it. Tenderly also allows you to upload the repo from GitHub into that analytic interface. But if the developers did not push this code to GitHub, then sorry, you cannot do the analysis in depth and decode the ABIs. Okay, say tools. Okay, can you give us tools for basic on-chain analysis? I think the major tool that you should I think you are already you're already conversant with. If you're not, you should be, is Dune. So this is the major tool almost every blockchain project makes use of. The analytic guy for almost all the blockchain project has a Dune dashboard for some certain data points for that protocol. Say Uniswap, say Curve, say Alve, say Compound, they all have Dune dashboard for their project. So Dune is a basic analytic tool you should be very conversant with. Any other question? So I'll wait 10 more seconds. Okay. With Tenderly, you can read the event and trace data, right? Yes, you can. You can read the event and trace data. You can. And you can also resimulate data, resimulate the transaction, and like try to mess up some data and see what's going to happen if the transaction had been sent in some other way. Any other question? So I'll wait again for 10 seconds.
You have a question in the chat.
Okay. I think I've answered that. That's with Tenderly, you can read the event and traces data, right? And yes, that's true. You can.
All right. So maybe we can round up here, right?
Yes, we can.
Okay. Thank you very much, developer Uche. Please let's appreciate developer Uche with some emojis. You can drop your thank you.
Thank you, guys.
Awesome. So I see someone with their hand. We are about to round up. So yeah. Do you want to attend to that question from the person who raised up? Okay, maybe it's a mistake. Yeah, thank you so much for the session, developer Uchi. We appreciate you. Sage, you can stop the recording. Thank you. Yeah, so we want to appreciate developer Uchi for the session. Thank you for taking our time to share some knowledge with us. It's quite it's quite a lot that we've learned from you today. Yeah, so thank you very, very much. All right.
Thank you, guys.